And I mean, I guess we called it A.
Right, so just call it A.
So this would be square root equals 1/2 A times dy plus 1/2 A times
Yes.
dx, thank you, plus 1/2 A times,
Easy.
And then factor out the 1/2 A's.
I am not your little monkey.
Oh.
Divided A's from both sides, then you wouldn't have the square, right?
As long as A isn't 0, we could divide both sides by
Then there
A.
would be a triangle.
Then there wouldn't be a choice. So I think we're okay with doing that. So,
I thought we pulled the 1/2 out too.
We did.
well, can we divide both sides by 1/2?
Yeah.
Multiply by 2.
But then you're changing it from a 4 to a 2, and you already did that.
You already, yeah.
You can't do that. You have to put the 2 back.
Yes.
Yes, yes.
Oh.
It was a 4, and then you already
Oh.
did
Very
that.
understood.
Okay. dy plus dx plus dy.
Okay.
3 times A divided by 2. That sounds, that's what we want, the square root of 3.
The unfortunate thing is now we've lost Kelly's idea of, oh, we had A, B, B, C.
That's what we
Right.
did.
But that's the dy dx dz.
Yeah. Yeah. But we don't want, in the end, we don't want dy dx dz. That's nowhere in our final state that we're looking for.
1/2, can you substitute that, because that's the same as 1, right? So, what's that?
This does tell us something really interesting though. This tells us that the sum, so what does this tell us? What are these?
Altitude. Those are all the heights.
Those are all the heights, those are these altitudes of this triangle.
Added
When we
together
add them
equals the
together,
whole
Wait.
height of the triangle.
yeah,
Wait,
it equals the
make
height
that.
of the triangle.
Wait. How do you know their altitudes?
Because they're
They're
We
perpendicular.
defined them.
To a point.
No, they're
Yeah.
perpendicular.
perpendicular to the
But
line.
she's thinking altitude of the whole triangle should go from B perpendicular to the side. She
Yeah,
was thinking
it's not
that's
coming
an
from
altitude.
B, it's coming from
Right.
Z.
And this is the altitude of this triangle.
Oh,
Oh, okay.
This is the altitude of this
okay,
triangle,
I
this
thought
is
you
the
said
altitude.
that.
So the sum of the altitudes of the individual triangles equals the altitude of the whole triangle. Oh, so this is something new that we had known. Sum of altitudes of original, sum of altitudes of 3 subtriangles equals the altitude of the original, no matter where that point is,
If it's equal out.
if it's equal out.
But we made it equal.
Right. So that's kind of interesting. So this,
So wait, that's
So-
over there.
so the sum, so these 3 so the sum here plus here will always be constant. It's fixed according to whatever your triangle is.
This is square root of 3 over 2a squared, right? Or, no, it's just 2a squared. And this is 1/2 ac times d.
Just call it A.
Oh, yeah.
You have an extra one in there. You got a little extra
One
something,
extra.
something
Yeah,
there.
It's okay, just erase it.
What have
But that's what we had before.
Yeah, but that's now the height of the whole triangle, right? Because so that's,
This?
no, dy plus dx
Oh,
plus
yeah,
dz
this is the height of the whole
is
triangle.
square root of 3 over 2a. But that just proves that there, yeah.
That just proves
that's-
it's the same.
Yeah, right.
Everything's in common.
Yeah.
And this should be.
Yeah.
4, yeah, you're right. It should be 4.
So yeah, left hand equals right hand.
Great.
Hey, yes,
We're done. Let's go.
we're done.
So, although we found something interesting that we've been able to prove, maybe this approach is not the best approach to try to tackle this. I mean, it got us something really interesting that we were actually able to prove that wasn't our original statement. So, let's try to look at it through a different lens as opposed to, and this is what's really hard for students, you need to now divorce yourself from the ideas of areas. Because that started us down this path. Let's examine this again, think about right triangles, and attack it from a different perspective rather than, oh, if we've got these right angles, I can find the areas. Are you all with me? Okay, so let's,
The means is there a squared plus b squared equals c squared?
Sides.
Yeah, the sides. Think of the sides, because that's what we're trying to look at, is the side lengths.
so you're thinking now,
Proportion.
look at
Look at
Pythagorean theorem ideas.
maybe.
So, for example,
Triangle ADY.
right here,
Yep,
that's a right triangle.
yep,
And we want an AY somewhere.
right.
So we've got AY squared plus BY squared equals AB squared. Alright, now I'd really like a CZ somewhere. I'd really like a BX somewhere. Actually, we've got 1, 2, 3, 4, 5, 6 right triangles. So let's just put all of those up there and see if it helps. Alright, so I will do the select work for you.
Thank you.
What are y'all thinking of doing? What are y'all thinking to do? What's going through your head?
I'm not sure if it'll help, but I'm thinking, AY plus YC is equal to AC, so adding the segments together. But we're gonna need that AC eventually, as well as AY. And then the other two. to be.
Anything strike you about something you can do with these?
Some of them are equal,
Mm-hmm.
so triangle,
Like these two.
right,
You could say cy squared plus dy squared equals cz squared plus dz squared. Which, if I add the left-hand sides together and add the right-hand sides together, that should make equivalent sums. And notice the dy squareds, the dx squareds, the dz squareds would all drop out.
Yes. Okay.
Yes, no, how? So see if you can take it from there with this, and I think you should be able to prove it with those. Because now we've gotten rid of information that we actually don't